Well, hello from my office here at West Virginia University. Today we're going to work through the requirements of my session at the 2020 IDEA User Conference. So, you can see the Word document over here. We're going to be using the Somerville file that contains check payments for the city of Somerville for 4 calendar years. So, we have the Word document. I have the details over here. And this document is posted in a Dropbox folder, and the link to the Dropbox folder is in the description below. So, import the Somerville data. We'll do desktop. It's an Excel file. Let's go find it. There it is. Open. Now, I've pointed to the file. It's an Excel file. We'll do next. We can skip that little warning. So everything looks good, except I'm going to abbreviate the table name. So I'm doing a backspace over there, and we will do OK. Nice. I think everything is good. Now I have a second document, which is over here, and these are just my notes. I have control totals. I have a dollar total over here, and I have the number of records. I need to check that my data import is complete, and I can see the number of records down here. I'm pointing at the bottom right, and I'm going to go and use control total amount OK. Yes, here we go. And I have a control total over here, and that total balances and reconciles and agrees with this total over here, so I'm good to go. My first requirement. What I want is a graph of the 48 monthly total for the invoices. There should be 48 totals, one total for each month. And this is one of my high-level overview tests. This is my book, Forensic Analytics. Note, it's the second edition. Chapter 2, the initial high-level overview tests, and we can see I have a periodic graph here, and I talk about this graph on page 59. So, this is what I want. The section starts on page 58. I want a graph of the monthly totals. This is the data for the book, and this is the purchasing card data, and you can see I start with 2009-1 and I end with 2014-12. Not all the labels are shown, but I have a monthly total, and we can see that we have spikes. September is a very busy month for purchasing cards, and we have 2 extra spikes over here, and I talk about this in the book. But for now, we're going to do a periodic graph of the data that we have. So, back here, I need a new date field, and I need to identify each transaction as belonging to, well, 2013-1 all the way to 2016-12. It's going to be one of those 48 months. I need to actually create this field, and to do that, I need to get busy. Since I never use this, we will go hide, right-click, hide. Okay. Now, I'm going to create a field. Remember what I want. I want fields that identify each transaction as belonging to 2013-1 to 2016-12. So let me go here. I'm going to go data append. I'm going to append a field name called year_n, and I'm going to use that n to tell me it's numeric. And the reason I'm going to do the _n is because I'm going to use a function year, give me here of check date. I'm just going to evaluate the first record. Looks good. And we'll go yes. And the reason that I call it year_n is because I don't want a field name that has the same name as a function. Otherwise, it's very easy for IDEA to get confused. Do you mean the field year or do you mean the function here? Y-E-A-R. Let's go. I got it. I have the 2013s over here because it is 2013, and I have the 2016s at the bottom. I need another field called month underscore n. We leave it as virtual numeric. I'm going to do the parameter over here, and I'm going to use date, month, click check date, and there we go. Let me see if I can make this a bit bigger. There we go, easier to see. Now, we're just going to evaluate the first one. It's 1. I don't want the decimals, but it will get rid of that. Here we go. Okay. Well, I have the year and the month, but they are in 2 different fields, and I need a single field, 2013-1. So let's go back again here. Append. Field name, we'll call it year, month. It's a bit long. Parameter. I'm going to go year, but what I want is I want string of year. This is going to have 4 characters and no decimals. This should work. Let me go and evaluate. Syntax error. I should have put an at there. There we go. Much better. There we go. Plus, now I need the dash, and I'll get that with quote, dash, quote, plus. And now I'm going to use the string function again, and I'm going to use it on month, comma 2 characters, no decimals. Let me evaluate the first record. There we go. 2013-1. This is good enough for me. I just have to remember now that this is 7 characters long. We'll go here. Length. It's not going to be virtual numeric, virtual character. Length 7. Here we go. I'm just going to check it again. We're good. We will do OK. Now, I can see that it's character because it's on the left. 2013-1. Each transaction has got a year, dash, and the month as an indicator. What I want to do is I want to get a total for each month. And so we are going to do summarization, field to summarize, year, month, criteria, create month total to, numeric field to total amount, sum, and we will do OK. I like it. I have 48 records, I have year, month, I have the number of records, and I have the total per month. Now I can do the graph, and that will be quite straightforward. Let's go. The X field is year, month. The Y field is the sum of amount. X-axis title, I can do date. I can do total amount over here. It's bar, and I should be good. I've got it. We go from 2013-1 to 2016-12. I have the monthly totals, and we can see I have a very high total for 2016, month number 6. So, this is my graph. We're not going to interpret it now. We actually just did it. Sorry about that. And here we go. Back to our requirements. Which month has the highest total over the 4-year period? So let me go back to my data. There we go. I want the months with the highest period, and to do this I'm going to do top records. So we'll go top records, number of records to extract 1, the top record for amount sum. I'll take all the fields, it's okay. And there we go. I have the top records. It's telling me 2016 6, amount sum 46 million and change. So that is the answer to number 3. Use the field statistics to establish the following values. So I'm going to close, close, close. Much easier if I do the statistics right here with only one open. Field statistics is over here. We'll do yes. Now, I have almost everything I need in the amount column over here, except I don't have the median and I don't have the mode, which is the most frequently occurring value. So let me go and calculate the mode. I'm going to go back to my data. We'll do summarization, field to summarize, amount, create, we'll call this number dupes, numeric field to total, we'll do amount, but actually I care about the count. So we'll do okay, and the count came along for the ride. I just need to sort and click the other way, and now we calculated the sum. The count came along for the ride, and what this is telling me is that $135 occurred 690 times, and it was the most frequently occurring amount. It is indeed my mode. As regards the median, I talk about the median over here, and I actually show that the median is 504.30, but I calculated this in Minitab, there it is, and I showed and talked about how to do it over here. You should be fine if you really do want to get the median. So, the mean of the data set is 12,144.64. Would you expect the average of a sample of 200 records to equal the amount? If not, would you expect it to be higher or lower? Also, I will include these 4 PowerPoint slides. These are fairly basic concepts, so you can read about it. And in summary, the average of the sample is an unbiased estimator of the population average, and it should be slightly below sometimes and slightly above other times. We do expect the check payments data to follow Benfords Law. Yes. In general, accounting and finance data follows Benfords Law. Run the first 2 digits test on the data. Show a screenshot of your graph. So this is nice. I'm going to close this out here, get back, and we are going to do Benfords Law on the amount field. Benfords Law, field to analyze amount. We're going to analyze the positive numbers. We're going to create a result. I'll take first 2. I never used first 3. Second digit only occasionally. Last 2, no. Second order, no. Summation yet, yes. Suspicious, yes. And we will do okay. It took Benford 6 years to do 20,000 numbers. We did 55,000 numbers in under 10 seconds. First digits, first 2 digits. So here it is. My first 2 digits go from 10 all the way up to 99, and I'm looking at the leftmost digits of the number. 0 is not admissible as a first digit. So we go from 10 to 99. The center line is Benfords Law. These are my upper and lower bounds, and if I protrude above the upper or I go below the lower, I have a statistically significant difference. My 3 largest deviations are for 50, 75, and 78, and that's because these are color coded a slightly darker red or orange than those. So 50, 75, and 78. Run the first two digits. I got my graph. What level of conformity does the data have to Benfords Law? It's up here. Marginally acceptable. The graph is not bad, and it definitely isn't good. It's also slightly worse than acceptable. It is what I call marginally acceptable. And for a little bit more about this, we can go to the book, and we'll jump to page 114. And in the book, I talk about the mean absolute deviation, I talk about the ranges, I talk about the conclusions, close, acceptable, marginally acceptable, and non-conformity. This table is based on these data sets over here. Those data sets had no fraud, no errors, they were good, and based on the results there, I created this table, and this table seems to have stood the test of time. So that's where it comes from. Let's get back to idea and back to our requirements. Identify the first two digits that have the three largest spikes, and that is exactly it. 50, 75, and 78. And indeed, I can drill down. I can go find these numbers. We can click on this. Display the suspicious records. Here we go. And these are all the numbers beginning with 75. Let me sort it. So I have some large numbers beginning with 75, and it's sorted from largest down to smallest. And all these are payments to banks, and those types of payments are probably okay. So, number 10 done. Identify the round number payments in the data. Define a round number to be a number that is a multiple of 100,000. And calculate the round number percent. So let's go here. I'm going to go back to my data. I have it. What I'm going to do is I'm going to create an indicator field over here, and it's going to indicate whether I have a round number or whether I don't have a round number. So let's go here, data, append. Field name, round num, virtual numeric, it's going to be a true false, number of decimals, here we go. And now, we are going to use the mod function. Amount, mod, which is the remainder, 100,000. What it's going to do now, it's going to divide amount by 100,000 and give me the result. If the number is a round number, in other words, a multiple of 100,000, that result is going to be 0. So we're going to go equals 0, close my brackets, and now it suddenly becomes a true-false field. In other words, if the remainder is equal to 0, it will give me a 1. If the remainder is equal to something, it's going to give me a 0. So it's a bit strange. We're looking to see whether the remainder is 0, and if the remainder is 0, it's going to do a 1. Let me just check how this works. This is good. Appended field, okay. I have lots of precise numbers. These are the zeros. The round numbers would be the ones with a 1. And let me just go back to the requirements here. Calculate the round number percentage, which means I need to know how many round numbers I have. I'm going to actually extract them. So we'll go analysis, a direct extraction, records to extract all. We'll call it round numbers. And the criteria is that round num equals 1 amount greater than 0. Let me just evaluate this. Here we go. And I'm going to go yes. And we will take, I don't think I need this. This. We'll just do an OK here. OK. There we go. I have all the round numbers here. Let's sort this. There we go. I have all the multiples of 100,000. There are 31 of them. And indeed, to answer the rest of the question, the round number percentage, I had 32 over 55,746. I need to change that. There are only 31 round numbers, and so I will change that answer. I probably went to row number 32. Use the day of the week to create a virtual numeric field to see whether we have any payments that were made on a Saturday or a Sunday. So the first thing I want to do is use the day of the week to identify the day of the week that the payment was made. So we close this here, and now we're going to go data, append, and we'll call it day week. We'll go for the parameter here, and we'll take date time, and we'll use DOW, which is day of the week, on check date. Evaluate, looks good. Check. Okay, here I have it. Day of the week. Sunday being 1, Saturday being 7. I have the day of the week over here, so now I know what day of the week it was. Use analysis, summarization, to count the number of checks paid on each day of the week. I need the count, and the count is going to come along for the ride. So let's go here, analysis, summarization, field to summarize, day week, create an output table, pay day. We'll do amount, but I don't really want the sum, I actually just want the count. So we will do OK, and so I really just care about the count over here. And indeed, day of the week 1, I actually have a payment that was made on a Sunday. Show the first 8 rows. Now, were any checks paid on a Saturday or a Sunday? Show a table of your results. So this is the table, and indeed 1 check was paid on a Sunday, and there it is. If I want to get that, we will simply go a direct extraction, and we'll call it pay Sunday, and the criteria is day of the week equals 1. We'll do OK, and I need to get just 1 record here. Which fields do I want? That should be good enough. OK. There we go. There are the details. That indeed was a Sunday, and they paid this on a Sunday. So let's close this. Let's close this, and we're back to the checkbook. And we're almost done here. Use this routine and tell me what was graphed on the top right. I like this. Here it is, visualization discover. Nice. Oh, this is really nice. We have a whole number of insights here, descriptive statistics, we have graphs, pie graph, and the like. And basically I ask what is happening here, and in this graph it is counting the number of payments per quarter. So we'd realize we have 16 quarters in the 4 years, and this is graphing the count of the records, the number of payments in each quarter. I like this. We can see here we have 0 items, we have negative records, we have control total over here, we have the average that we spoke about before, earliest and latest check date. I like this routine. It does a nice job. X out. When you X out, it's kind of gone. And one more. See whether we have a vendor with Christmas in its name. Show a screenshot of your results. And indeed, I need to actually go here. Data, search, search. Text to find Christmas. Look in the vendor name, and we'll create an extraction database. We'll call it Christmas. Okay, isn't this nice? I do have a vendor with Christmas in its name. And we can see the amounts and we can see the dates. And indeed, for my students, I asked them various questions about this, and I asked them whether these transactions are suspicious or not. And indeed, they need to tell me why. That was that requirement. And I think we're done over here. Create a table of the transactions, show a screenshot of your table. It's been a bit long. I've enjoyed this, and I hope you have too. And so from me to you, it's bye-bye.